Okay, so moving on. Next thing I need to collect is the type, right? So the type, I decided to store type as a character, not as a string. So I will be collecting a character. So again, something similar to making all of these inputs. It's kind of long code, but that's fine. So let's say enter C for cat, or D for a dog, right? So for a cat, or D for a dog, okay? And we'll be expecting them to give us from standard input, basically input the type, which is a single character, right? So we'll be asking for a single character and storing it in a type, right? So right here, character variable is type, and right here the user will be giving us the information. Okay, next I need to enter age. I think I already did this for the pet owner, so I can just copy and paste pet owner age right here. But instead of asking for pet owner age, this time I will be asking for pet age. Okay, and that that's a little ambiguous because it doesn't say in what units of measurement. We'll be just assuming years. We can say pet age in years, right? So how many years old? That's fine. What else do I need? The color and adoption. Okay, so let's do the color and adoption. For the color, I can just say, color. I can do the same thing with the get line. Just keep doing get line for strings. So for color, I'll just keep it simple. Color, and input the color string. And adoption will be another variable. We can just say cout is this an adoption, right? And the answer will be yes or no. Okay, so we'll be accepting yes or no. This is Boolean, right? This is Boolean. So we can just we can try something like character answer, right? And we can say std input get answer, which is another single character, and we can say if answer, which is a character, is character yes, right? Then we will say that adoption equals true, right? Otherwise, adoption equals false, something like that, right? So we populate this adoption with true or false. Alternatively, we could use arithmetic if to populate the adoption value. I will show you how you can do this, right? So alternatively, you can say adoption equals, and use this condition whether answer is yes. So if the answer is yes, okay, then you can use question mark, then populate adoption with true, otherwise populate it with false. Both C++, Java, and other C++-like languages support this arithmetic if. Okay, so true or false, whichever way it is, it's fine. Arithmetic if basically says, give me the condition. If the condition is true, I will take this value. If the condition is false, I will take this value, right? So, but we can even simplify it more. We can basically, just the shortest version of it would be just this, right? Just say, evaluate this condition, whether the answer was yes. If it's true, adoption is going to be true. If it's not yes or y, then adoption is going to be set to false. So whichever way we do this, this is our choice. Anyway, I seem to have collected all of the data, but my pet class right here doesn't have a constructor. Obviously, I would like to construct a pet by populating it with all of these values, right? So I need to create a constructor. So normally to create a constructor, to add a constructor to a class, we just use pet, right? We just, first of all, the constructor needs to be public because it has to be usable outside of this class. And then essentially the list of this, obviously, this would be a default constructor. Default constructor, but if I wanted to populate my pet with all of these data instead of default constructor, I'll just hit enter here and just copy and paste all of this and use the list of the string, character, integer, string, and boolean as parameters. But as we know, when you construct a list of parameters for a function, instead of using semicolon, we need to change this to a comma, and then the last parameter does not need the comma. So we need to make some updates here like this, right? So this, because it has a semicolon and doesn't provide any executable code, this is just constructor prototype. To make it a real constructor, we can copy this, Control C, and I will move this pet license implementation to the previous tab group so that we can see it side by side. And I will simply just copy and paste this declaration over here. Of course, because this is a name of the constructor, it has to be prefixed by the scope from which it comes from, which is the name of this class. Class pet has constructor like this, and these are the parameters. Then, of course, if you select this and use like Shift Tab, it brings you to the you can make adjustments to the way you're formatting your code. And then, of course, the actual initialization is going to be done using again, using this initialization list, right? Same comment that I did for the pet owner, right? This, just a reminder. Of course, this is silly comment because you should recognize that constructor in C++ using a colon basically is using initialization list followed by an empty constructor body because all we do is just say, let's populate the name of the pet with the parameter name which was given to us, right? Let's populate the type of the pet with the type that was given to us as a parameter. Then age, the same way, right? We just populate. This is a lot of this constructor work is very, it's not very interesting. It's kind of boring stuff. Color. So we're going to populate the color with the color that was given as a parameter, and then of course the adoption. All right, adoption is the same way. Adoption, and we will populate adoption with whatever adoption was given to us. You can see that this grade color in the syntax highlight in my source editor indicates parameters that were given to this pet object constructor, and then this is where they used to be used in order to populate the individual attributes, right? So this constructor list, just a reminder, is similar to saying name equals name, right? Name equals name, just using normal program statements to do this. Okay, but so this would be similar. You don't have to do this if you follow me. I just want to demonstrate this very quickly, that it's essentially, this would be similar to what Java does with inside the constructor. But of course, in C++, you need to disambiguate the name by saying this name, to disambiguate the name of the field inside the class from this parameter, which was given to the constructor as a parameter on the parameter list, right? So this would be this can be done like this with using the actual full syntax like this, but using assignment statements are considered to be inefficient. Because initializer list actually executes as soon as memory is allocated for the object. Basically, you can consider that these values are pasted directly into the memory where the object will be constructed, whereas this list of statements, which are just assignment statements, would be executing already after memory is allocated. So in C++, this is a wrong way of doing it. Okay, so that's why I'm just going to delete this from my constructor. I'm just basically relying on the initializer list anytime I'm constructing my objects. All constructors normally in C++ use initializer list instead of this, right? Instead of using assignment statements inside the constructor. The assignment statements are considered to be too late and too slow for this type of job. So just for the demonstration's sake, I will comment this out and will say that this is not recommended in C++ because initializer list syntax is available. However, in Java, this is how you initialize your data members. Okay, Java does not support initializer lists. It just supports the normal syntax of your data fields and assign the values to them. Okay, so this is my constructor right here, and of course, let's now create a pet. Right, so I can use something like this: pet, construct my pet, and give it all of these values that I collected from the user, which is the name, right, the type, the age, the color, the adoption indicator. Altogether 5 parameters. So this syntax constructs an object which is an anonymous object, which basically gets constructed. In my case, creating an anonymous object is okay because I have my owner, right, the pet owner, which I created earlier on, I believe, right? Where was it? Pet owner, right? The owner I created, name with name, age, and address, okay? And so therefore, now I can say owner add. There is an add method which we added earlier on, and all I need to do is essentially pass this pet object to my add method inside the owner, and essentially just call this this function add inside pet owner. If you notice, pet owner has an operation named add, function member function named add, and it simply takes reference to the pet which we have created. So that should be able to insert this pet into this collection right here, right? So it's this obviously is my owner, right? Is my owner object, and when I say owner.add, and I say this pet with all of these parameters, right? When I do something like that, this pet object gets created, and a copy of it will be inserted into this vector right here. So this is what add does. Because if you look at the implementation of the add method, somewhere in this implementation file, here's the add. It basically says, okay, give me your pet, and I will add it to the collection of pets. And of course, collection of pets is a vector of pet objects. So I'm just assuming that this will all work. Now notice that I pass this pet by constant reference, but compiler should be smart enough to make a copy of this object before it gets inserted into the pets collection. So I'm expecting that my collection will be properly populated. So let's save this, and so obviously I have some leftover code which I will now remove from there, but this will be my experience. This is the user experience of those two nested while loops. Now, one thing is that I was asking the number of pets, right? I was asking how many pets would you like to enter, but this loop is endless, and it will be just populating everything with endless list of pets. The user will never get out of this loop, so I need to change this. Let me save everything first.